Hello, my name is Professor Johnson, and today we will be talking about the binomial distribution. Now, with the binomial, we really think of two possible outcomes, and usually we are talking about a success or failure. Okay, so only two possible outcomes are available to us. Now, in this video, I will be strictly using the TI-84 plus. TI-83 follows the same directions in my examples. Now, with the binomial, mu, our mean, is equal to n times p, and sigma, our standard deviation, is equal to the square root of npq. Okay, so we'll need those formulas most likely when solving homework and all of that. So n, what we consider n, is the number of trials. Okay, number of trials. And these number of trials must be independent and identically reproduced. So like flipping a coin over and over and over. Every time you flip a coin, it's independent of the coin flipped before. Or if you roll a dice, rolling dice over and over, those are independent trials. So you're counting number of trials. Okay, then p, that little p, is the probability. So probability of a success. So it's the probability of a success occurring. So Q is the probability of failure, and that'll just be whatever's left over, 1 minus P. So just remember Q is 1 minus P. That relates to the failure piece, and success goes with the little p. Okay, so let's look at an example. Pretend we roll a 6-sided die 20 times. Now that 20 right there, that 20 times tells us n is equal to 20. And we'll use this throughout this whole example. Okay, if we roll a 6-sided die, you could imagine that on each side you have a 1, a 2, 3, 4, 5, and a 6. Okay, so what is the probability of rolling a 5 exactly 8 times? So imagine you've rolled the dice 20 times. So over and over and over, 20 times, you keep reproducing it and you record all of your responses. Now, in theory, what's the probability of rolling a 5? Okay, if we think of just one roll, so look at the probability of success. Getting a 5 happens 1 out of the 6 sides. So this is my probability of success, 1/6. Q would come from everything else. So everything else would be 1 minus the P. So 1 minus 1/6 is actually 5/6, because not rolling a 5 would be rolling the 1, the 2, the 3, the 4, or the 6. And that's really 5/6 probability of happening. Okay, so we have our success, and then we have our failure. Okay, probability of rolling the 5 exactly 8 times. So with my probability notation, I'll say x is equal to 8, because this says exactly 8 times. Now, like I said, I'm going to use the calculator to find this, and if you go second vars brings you to the distribution buttons. And our distribution that we're talking about today is binomial. So if you go down, it'll be towards the bottom, and you see binom, two spots, binom PDF, binom CDF. Now, because we're in the exact case, we're going to be using PDF. So I'm going to pick binom PDF for my example here. And when you pick binom PDF, it's going to ask you for 3 things. The number of trials, which we know was 20. It's going to ask for the probability of a success, which we know was 1/6. And then the x value comes to what we were interested in, is the 8. So I'm going to type in 20, 1/6, and 8. It always goes in this order. It always goes in this order. So when I hit enter, you can see that it put it to the main screen exactly how I wrote it on the screen here, binom PDF. 20, 1/6, comma 8. When you hit enter, let's just round to 3 decimal places, 0.008. So that is our probability, that's our chance of getting 8 5s rolled in that 20. Okay, exactly 8. All right, now if we go to a different type of example, what is the expected number of 5s rolled? Expected number, you could think of expected value or the mean, and the mean is really mu. So n times p. Okay, mu is n times p, and n, that goes back to the 20, and then the probability of success is 1/6. So if we use the calculator, 20 times 1/6, that is 3.33. Okay, that's repeating. So about 3 of the 20 rolls, or 3 or 4 of the 20 rolls would have been a 5. Okay, that's what's expected. You could also think of expected value. Now, if we know that that's expected, so about 3 or 4 out of the 20 will be expected, how about we look at this? What is the probability of rolling less than 3 5s? So we know that 3.33 is expected, so what's the probability of rolling less than 3 5s? So we want the probability that x is less than 3. Now you see here that we're going to the cases below 3. Since we are in a binomial distribution, we have discrete cases. Okay, we have the discrete cases. And if you think of a number line, it's possible that you roll no 5s. It's possible that you roll 20 5s, right? Theoretically, you could roll, every time you roll the dice, you could get a 5, a 5, a 5, all the way 20 times. All 20 rolls could be a 5, or none of them could be a 5. Now, what we're interested in this example is less than 3. Now, less than 3 includes the 2, the 1, and the 0, okay? It includes these. It does not include the 3. 3 is not included. So, when we write our notation, we're going to put before we get to binom, we'll say probability that x is less than or equal to 2. Really, you're starting at the 2, right? So now we can write binom, and because this is adding up multiple cases, the 0, the 1, the 2, we're going to use CDF. The C stands for cumulative, so you're adding up different values. And when we use the CDF button, it goes in the same order as we did before. You have the 20, then you have the probability of success, 1/6, and then now you put the x value that you're interested in, which is the 2. Okay, so let's go to the calculator. Second vars brings up the distribution. A hint, if you hit up, you'll go to the bottom real quick. Pick CDF because we're accumulating the chance of 0, 1, and 2. We have 20 trials. A probability of rolling a 5 is 1 out of 6 on the dice, and the x value we have now is 2. We'll paste that, and then we can see that this is, the chance to occur is 0.32, and if we round to 3 decimal places, 329. Okay. Now this is one way to do it. There is another way that's possible. You could add up a PDF. You could add up the PDF for 0, add up the PDF for 1, and add up the PDF for 3. You could add all of those up, would give you the CDF for this. So you could, I encourage you to practice that in the calculator. Use the PDF, add them up, those 3, and see if you get the CDF. Okay, thank you for watching.